So you're used to it if I say, here's a vector 1, 3, 7. It moves 1 in the x direction, 3 in the y direction, and 7 in the z direction. But what if I just tell you where it starts and where it ends? Don't overthink this. This is not supposed to be super hard. If this starts at 1, 2, 3, and it ends at the point 4, 1, 7, you should be able to figure out its vector. Those are points. It's easy to get confused about points versus a vector, but 2 points can make a vector very easy. So figure out the vector for that. I'll pause for a second and give this a try. So the kids figured out that the vector was, when I went from 1 to 4, it went 3. When I went from 2 to 1, it was -1. It went from 3 to 7, it went up 4. So that was the vector. Now write an equation for it. Okay, so if this one starts at 1, 2, 3 and goes the vector of 3, -1, 4, then the only thing I need at the beginning is either an r equals, like vector r is, or you could, for instance, do x, y, z. My opinion, best to say x, y, z right here. So why is that my opinion? It's best to say x, y, z right there? Because later you might want to write it in parametric form. Would everybody please write this vector equation in parametric form? Kind of giving you a little tour of stuff you've learned. That's what's happening on the test. All right, you should have said x equals 1 plus 3t. Next, you should have said y equals 2, and I could say plus -t, but it's just so much messier than just saying minus 1t, and then it's even cleaner to just say t. And then last is z equals 3 plus 4t. All right, so there's an equation that's in parametric form. Why is that any better? Because then if I had another equation, I could make its parametric form, like if I had a completely different equation up here, and then I could set their parametric forms equal and solve. We've practiced that enough that I don't want to do another one right this second. You have one to do on your quiz that you'll get back today, and then have a little bit more time, and then we'll grade it. So you got to know about intersecting versus colliding. A lot of kids get confused. I even get confused. I made a mistake in this class the other day about this. I found out that when I solved that system of equations, I got something like this. And I said that they collided at that time. But they really just, when I get a solution like this, it tells me those 2 times were special because they went through the same spot at that time. But they weren't there at the same time. So I said it collided when it actually just intersected. All right, so let's say that this one intersects with another one at t equals 2. If it really intersects with another one at t equals 2, does that mean that they are there at the same time? If they intersect, does that mean that they are there at the same time? No. The word collide is when you're in the same spot at the same time. The word intersect means that you go through the same place, but not necessarily at the same time. Okay? So figure out what that place is. If t equals 2 is the key moment, where is it? It's not here. And it's not here. Where is it at t equals 2? pass to next class. Nice one. So ready? Fill that up. Looks like that. So Marcus, where is this magical point? I'm going to personally make a T, X, Y, Z table. You don't have to. It's just a place to put it. And then I put the 2 here. And Marcus, what'd you get?
So X is 7.
Okay, so T's 2, X is 7, and then Y is,
0.
and then Z is 11, did you say? Okay, raise your hand if you had 7, 0, 11. Okay, cool. So at that moment, something important happened. Well, it could just be that they both crossed that path. If there's another equation, it may have just also went through 7, 0, 11. What if it did it at lambda equals 2? What does it tell you? Yes?
They collide?
That they collided. What if its solution was lambda equals 1? Well, then it was there at time 1. It was also at 7, 0, 11. But if this one's here at time 1 and this one's here at time 2, then they were there at that spot at different times, and therefore they did not collide. Okay, enough about that. Next, let's do another simple one where I give you a vector that's going this way and a vector that's going that way, and I want to know what the angle is between those two. So this one's going to be a vector that is x, y, z, I'll help you in just a second, is 1, 2, 3 plus t times 2, 0, 2. The other one, this one, is a vector, and you can tell they started at the same spot. So do you get, I have to start with a 1, 2, 3 here, because they started at the same spot. Okay, then I'm going to go plus lambda times 1, 0, negative 1. I want to know the angle between those two vectors, and you have to know a formula for it. We're not going to give it to you on the test. Hopefully you've memorized it, and it has cosine in it, and it involves dot products. All right, I hope you knew that this was the important part. Those two things. Now, if I do those two things and I get a dot product of 0, do you remember that that means that they are perpendicular to each other? All right. So that's like part of it is to find the dot product. So I would always start with that, because if I got a dot product of 0, I'm done. I know the angle between them. It's 90 degrees. Okay. So I'm going to call this, I'm going to use vectors v, hold on. I didn't give them names before, but I'm going to give them names now. V and J. And I would do the dot product of these two. Dot. You can't really multiply vectors. You can multiply the magnitudes of vectors, but you can't multiply vectors. Doesn't do anything if you do multiply vectors. But dot products, They're useful, especially when it comes to the angles between them. Okay, so then you have the other one, which is, some kids are going to say you multiply the vectors. You don't. You multiply the length of the vectors. That's a multiply. And then it's cosine of theta. Raise your hand if you had the formula right. Okay. Hunter, do you know what you got for the dot product? All right, then let's do it together. What's 1 times the 2? 0 times 0. Negative 1 times negative 2. Okay, I got 2, I got 0, and I got negative 2. Put it all together.
2, 0, negative 2.
And that makes
Dot product.
of, I don't think you know this. You want to add them all together. I think dot product is something you've lost. Here's how it works again. 1 times 2 plus 0 times 0 plus negative 1 times 2. And I ask again, what is the dot product? 0. There we go. And what happens if the dot product is 0? Yeah, it's perpendicular. The angle's 90. Done. Now, if you wanted to finish, let's just talk through why it would actually be that way. Because if I get 0 here, I don't care what number I get here, because I'm going to divide both sides by it, and I'll have 0 divided by I don't care what number. And do you get I'll still get 0? So no matter what this is, I'll divide both sides by it to get cosine alone, and I'll have cosine alone, and I'll have 0 divided by I don't care, and I'll get 0. And then cosine of what angle is 0? Come on. 90. Yeah. So this must be 90. And how do you know that? Because if I look at it, this is one of the quadrantals, and that's the spot 0, 1. And cosine is the x value of it, so the answer is I'm at this spot. And the angle, therefore, is pi over 2, aka 90. Okay. So there's a reminder about how to make vectors out of 2 points, how to find an angle between two vectors. We talked about colliding versus intersecting. We never actually found these magnitudes, but let me just ask you a simpler one. 1, 0, 4. What's the magnitude of this? And then use it to make a unit vector out of it. So if this is going to be vector Q, I'd like to know what the unit vector would be. I'll pause for a second. That'll make you find magnitude and do something else. Okay, so first off, you got to figure out this with the bars around it. Lucas, what does that mean when I put the bars around it?
That's absolute value.
You'd think so, but its name is magnitude. So, and it kind of works the same way.
Because magnitude is like.
Because
it's
magnitude
just kind of
doesn't matter which direction it's going, it's how big it is. So it's kind of like an absolute
It's
value.
like
But
absolute value for a vector.
okay, good. So then, what is it?
That we learned yesterday.
Okay, so
Square
you.
root of x squared plus y squared plus c squared.
Okay, good. So what is it?
1 plus 0 plus 16.
So final answer?
Square root of 17.
Square root of 17. Now that should have been in your answer. Your answer then goes, if that's how long it is, I could have made it end up working out to be square root of 16, which would have been 4, and it would have been nicer, but then if I had made it 4, this would be 1/4 in front of it to shrink it down to a scale size of 1. But I actually use 17, so I go 1 over root 17. And why don't I leave it that way? Because I then said, I want this to be 16 units long. Right? I think I said 16, didn't I? Okay, so then you're going to multiply it by 16. So I'd be fine with it being in front like that. Even better, it's really 16 over 1, right? So then you may as well just put the 16 right there. Either way works. But there is your vector. And yeah, you could, if you wanted to, multiply it this times 1, this times 0, which is of course still 0, and this times this, and multiply it all out and get your answers that way. And so if you're looking at the key, that's probably what they would do. All right, so there's your vector that's 16 units long in the same direction. Okay, so what else do we do with vectors? Can you name any other thing that we should review? While you're thinking that through, I'm just going to give you one more point where I give you, like, here's a triangle, and it goes between these 3 points, 1, 1, 1, in 3D space, 2, 1, 3, and 1, 7, 10. I'd like to know what the blue vector's name would be. Like, this is a point, this is a point, and this is a point. None of those were vectors. So what's the blue vector? Okay, so while you're working on that one, think about, is there anything else you want to ask me? We haven't covered everything. So what's the thing we haven't covered? You think of what vector thing we haven't talked about yet? All right, Adam K., what did you get for the vector that makes this blue arrow here? Okay, we did one earlier this hour. Don't remember it? When you go from 1 to 2, how far did we go?
1.
Yep. When you go from 1 to 1, how far did we go? It's not that hard. This is why I'm practicing it, though.
You can't see what
You can't see the board?
you're doing. No, I can.
All right. I'm really honestly trying to help because I know it's on the test. So how much did we change when we went from 1 to 2? It went up 1. How much did we move when we went from 1 to 1? We didn't move at all in that direction. And when we went from 1 to 3, then it went up to 1, 0, 2. Raise your hand if you had that one right. Okay, good. That is the vector. So it's really easy because points and vectors look a lot alike. So that's the vector, 1, 0, 2. How long is that vector? Figure it out. It's the same as the magnitude. Hunter, you got this one?
No.
Okay, I'm going to call it vector M. And I just asked him, what's the magnitude? So I put bars around it of M. It's M. W. What'd you get?
Square all of them, square 1, square 0, square 2, and add them all up.
Yep, and then you take the square root. So square root of
5.
1 plus 0 plus 4. So, yep, square root of 5. Raise your hand if you had square root of 5. Okay, good. That's magnitude. Okay, so then what's the speed of this vector? Square root of 5. Speed is the same thing as magnitude because that's how far it goes in one time. We don't even know what the units are, but if I put in t equals 1, and it goes from starting at 0 and it goes to 1, it goes that far. That far in 1. So that's in 1 means like unit. So that's the unit rate, which is also known as the speed. So don't overthink it. The speed is square root of 5. All right. So we haven't necessarily reviewed everything, but we do have tomorrow also. And so what I want to do now is give you some time to finish up the quiz we had in class yesterday. Get a chance to get your head around those again, and then we'll grade them. That's just a formative grade. Then you'll have time to work on a worksheet, which gets you ready for tomorrow. Tomorrow in class we do a practice test. We're just kind of adding in this extra luxury day of seriously should be testing tomorrow, but we have extra days, and we don't need that many extra days to study for the final. And so I'm just throwing in an extra review day that we wouldn't really need. So we're gonna take a practice test tomorrow. Question?
Well, what year are we taking the final?
Good question. It does depend on the kid. If you're going to be with me taking the final, then that would be on the last. There's a finals week here at the high school. But I think the middle school kids, you're going to get given that in some way that I'm not like you won't show up for finals week here. The middle school kids are gonna be taking it at the middle school. It'll be given by some HP teacher or something. Does anybody know exactly, have you guys been told who's gonna be giving that to you? Okay, so, yeah, because the schedule is so weird, you'd be reporting here at a really weird time, that they're not gonna have you come here to take it. So you'll take it at the middle school, and somebody there will let you know. I can tell you this, you won't be taking it until the last week of school. And between now and then, you'll just stay here for all the review. Yes?
Do juniors have their MCA scores in?
We've got I don't understand why, but we have something called the tentative MCA scores, but we don't have the real thing. So I'm gonna wait till they give me the final, like, yep, those are the official scores. So I can't give them to you yet because I haven't got the official ones. I don't wanna give you tentative scores and then have to be the guy who said, oh, psych, it wasn't actually that. So I'll just wait till they're done. Any other questions? Okay, so that is all we have for new stuff for today. Is basically all review. Except I think the one thing that was kind of new was if I just give you a point and I give you another point, you got to be able to find the vector that goes from the one point to the other. And all it's about is the change. How much it went up when you went from here to here. It goes there. From 1 to 1, it doesn't change at all. And when you went from 1 to 3, you went up 2. Okay. All right. That's it for today.